So very good afternoon to all of you. And first of all, I would like to thank ma'am for providing me this opportunity to share my ideas on one of the most important technologies nowadays, which is called as blockchain technology. So you see that today's lecture is basically concerned about how blockchain technology has been revolutionized like anything from past few years, and then how various types of consensus algorithm had been used as far as the blockchain technology is concerned. So the content of presentation would be we will cover first of all the basic of blockchain, key components and terminology that has been used in blockchain technology. Then what is the overall blockchain structure and how consensus algorithm has been used for defining your own blockchain technology. So we are living in digital era nowadays, and you see that there are various types of what we call as the communities which are interconnected with each others, and these communities are interconnected with each others using internet. And then you see the prime purpose of all these connected communities basically all about so the prime purpose of all these community is primarily for data sharing, and these data sharing is all about we can say through the communication aspect. I mean to say there may be different devices which may be located across this domain. There may be different users who are located in this domain, and there may be some other users. So all of these users may be different part of the world, but their prime purpose is to share the knowledge with each other using an open channel, using an internet. And obviously the underlying network infrastructure or backbone infrastructure will provide all facility for secure data transmission, provide source allocations, and there are a lot of issues that may be addressed at this point of time. So the prime purpose of all of these is to generate communication with each other, or to have communication with each other, and some of these community may be interconnected and doing business with each other. So in this aspect you see that as we are able to communicate with each other using an open channel, so there may be some sort of attacks that may be happen, or information leakage may be possible. Some intruders may try to steal the information. So all of those I mean to say here, all of these may happen at any point of time. So our prime purpose is this, that how the information can be made secure whenever we are trying to have the information sharing over a shared channel, yeah, like internet. So there may be different participants associated, like for example I have already told you that there may be different communities which are interconnected with each others, and there may be they may be having some sort of financial transactions. There may be some having some sort of contracts. So all of those contracts transactions may be digitally signed. Those may be some sort of asset transfer. So those types of I mean to say here scenarios are already in practice, and those scenarios we are already using in our day-to-day life applications. So how to we can say secure the information which has been shared among these different communities across different geographical vertical. That is one of the key challenges now the communities are looking for. So you see that most of the traditional most of the traditional we can say mechanism using which this information is shared is based upon this centralized architecture. So this centralized architecture, let's say we have different parties, party A, party B, we have some bank records is also there, we have some audit recorders are also there. So all of these are sharing some valuable information using an open internet and using an open channel which is called as internet. So you see that most of them are dependent upon this centralized architecture. So this centralized architecture will be just like a facilitator which will provide the information sharing between different stakeholders. But you can imagine that if this centralized node may get maybe overloaded, or this may be due to some point of time may have some crisis. This may have some breakdown. So you see that whole of the information which is shared among these different communities may go down. So better solution will be this, that instead of maintaining all these records in a centralized node, what we can do is that we can move toward this distributed architecture where each of these nodes maintain their own, we can say, information, which is in the form of digital ledgers, which these distributed ledgers maintains their information, like here. And this information basically is to be stored across different geographical verticals, and each of these having a digital signatures which will be used for identification, that which to perform various types of operations. So we have a good idea that we can be able to identify that who is the owner of that information. So that is one of the key concern nowadays, that if that information comes from an individual, so we should be aware of that, who what is the identity of that particular person who is sending that information. So that information which is shared among different communities, so we can identify each individual and identity of each individual with the help of digital signature, which is one of the key concern nowadays for maintaining the secure information. So there are some inherent benefit of using of blockchain technology for today's part of for today's scenarios, where we have different types of IoT devices which are connected with each other. So one of these is that it will reduce the overall cost and complexity, and of course it will provide trusted record keeping mechanism. So we can make sure that whenever the record keeping, or we can say the information storage is concerned, so this information should be secured in a trusted manner. So this can be done with the help of blockchain technology. Then it will also improve the discoverability. So discoverability is that we will be able to identify that which particular node is used to transfer, or which particular record is to be fetched out from a particular node. That should also be taken care of by the blockchain, with the help of blockchain technology. So all of these facility has been provided with the help of blockchain technology, and this can be one of the, I mean to say, key benefits of using of blockchain technology. And more important part is this, that we have the shared trusted processes. So all of these processes which a particular people which a particular node want to share with each other, so these can be with the help of shared trusted processes. So uh, you see that in the modern way, in the modern scenario, we will have two types of scenario. One is with the help of centralized node, and second is with the help of distributed peer-to-peer type of scenario. So blockchain follow the second scenario, which is basically based upon peer-to-peer scenario, where each of these nodes maintain their own records, while in the case of the centralized part, each of these node maintain or dependent on this centralized node, which may have maybe fall down, or which may have breakdown, or which may have some sort of we can say overloaded at certain point of time. So this is the beauty of this technology, that it's not dependent upon a fully centralized architecture, but it is based upon a fully distributed architecture, in which these different nodes maintain their own records and maintain and they may be used for asset transfer, or they may be used for different types of we can say information management at different point of time. So what exactly is blockchain? So you can see that if we try to find out the exact definition of blockchain, so it is nothing but it is in nutshell we can say it is a chain of blocks. But key question here is that comes in our mind is what should be the inside that particular block. So block is nothing but it is just like a data structure which is used to connect with other block, and block is just like information carrier point. So let's say we have some information in this particular block, we have some information in this particular block, we have some information in this particular block. So all of these blocks may not be independent, but these are interconnected with each other. So these interconnection between different blocks will be provided with the help of some sort of, we can say, back pointers, and that back pointer is basically used with the help of hash value. So this hash value is used to integrate different blocks with each other. So like for example, if this particular block is there, so this block may consisting of some data, some transactions which had been processed by a particular node, and also it has a previous hash value as one of those attribute, and current hash value of this particular block. So this will be an attribute for the previous block, and hash value of this particular block will be an attribute for the previous block. So you can see that each of these blocks are interconnected with each other like this. So we may have another block, the hash value of this particular block will be an attribute for this particular block. So so key question here arises again is that, let's say if some attack happens on this particular node, attack in the sense that information has been changed, or there may be some attack that may happen, or some attacker has changed the hash value of this particular block. So what will happen to that particular blockchain? So you see that if some attack happens on this particular block, so subsequent blocks or subsequent chain will becomes invalid, because you see that a particular property of the blockchain is that whenever we have a single bit of information is changed, so we have a completely new hash value. So in that particular hash value will not match with this hash value, that hash value will not match with this hash value, or subsequent hash block will not be a match with the previous block. So you can see all this chain beyond this block number 3 will becomes an invalid chain. And if that chain is to becomes valid, or if attacker has some potential that how to compromise all the subsequent block from block number 3 onwards, so he has to change the hash value for all of these block at the same instance of time, which is quite impossible, as we are dealing with a large number of nodes in the blockchain nodes, and we didn't know where that particular node is located. So in nutshell, we can say that it is almost impossible to attack a blockchain, because at the same instance of time the attacker has to compromise all the nodes at the same instance of time, which is practically impossible, because we are dealing with a large number of nodes in the blockchain. So that's why the chain is found to be secure. So like this is cryptographic hash linking of different blocks. Like for example, let's say we have this block is connected with this block is connected with this block is connected with this, and all of them are connected with the hash value of previous block is one of the attribute from the previous block. So this is the beauty of this particular technology, that it will provide us a more leverage, or we can say more flexibility with respect to the attack defense scenario. See, so this is blockchain is basically based upon distributed ledger technology. Distributed ledger is, I mean to say here, there may be different nodes which are interconnected, which may be located across different geographical locations, and these nodes are interconnected with each others, and with, with the help of this decentralization, they are maintaining their own records. So if we take about a general example that how this let's say let's say there are two users, and one of them is want to transfer some finite number of assets to other users. So let's say someone has requested a transaction, so he broadcasts that transaction on the existing blockchain networks which is already in place. And in this case, because we are not dependent upon any centralized node, so all of these nodes which are already in place, so they will act as a validators for this transactions which has been broadcasted by this user. So that transactions which has been broadcasted by these users, so those transactions may be valid or those may be invalid, but the task of these validator node is to identify that these nodes this transaction which has been broadcasted by this node is valid or not. So they will validate with the help of consensus algorithm. Consensus means to say that we have some agreement among all these nodes uh, to mark these transactions as valid or invalid transactions. So once that agreement has been reached between these nodes that these transactions are supposed to become as a valid transactions, so they will become as a part of this block, and then this block will be added at the end of the chain, and the size of the chain will go on increasing. So you can see that there may be certain transactions which cannot become as a part of the block because those transactions has not been validated by all of these validated nodes. So only those transactions which has been validated by all of these with respect to an agreement which is called as consensus algorithm. So with the help of consensus algorithm, so these transactions which has been broadcasted on this blockchain no on the blockchain networks will becomes as a part of the block, and then this block has been validated. So once this block has been validated, so this will becomes as a part of the chain, and this will be appended at the end of the chain, and the size of the chain will go on increasing, and finally this transaction which has been committed, so finally this transaction has been committed. So you can see that the heart of this blockchain is located at here, where obviously there may be different consensus algorithms are there, and we can use any consensus algorithm, and we can design our own consensus algorithm as well. So based upon the uh, applicability of these consensus algorithm, based upon the application or we can say difficulty level of these algorithms, we can be able to identify that how these algorithms can be executed for secure transactions between different end users. So this is one of the property of any blockchain technology which has been revolutionized like anything. So this in nutshell we can say this is the overall structure of how this a new block has been added. So you can see all of these blocks, once those blocks has been validated, so these blocks will become at the end of the chain, and the size of the chain will go on increasing. So on Ethereum platform, after every 10 to 15 minutes we will have a new block to be added at the end of the chain, and you can see that how large that size would be there, because it's a public blockchain network. So every 10 to 15 minutes we have a new block to be added, but obviously this block must be validated by all the validating nodes which are participating in the blockchain network. So and that's why you can see this is the overall structure of any blockchain networks in the existing blockchain networks. So how does a particular block look like? So a block look like consisting of certain level of data elements. It consisting of the transaction which has been committed, and it consisting of various transaction list which has been processed. So these are some sort of, I mean to say here, component associated with any blockchain networks. So we can have first of all a version number, that is a block number associated, but for for a particular block, and then we have some nonce value, and we have timestamp associated, and then we have the Merkle root hash tree, and then we will have the various types of transactions which has been processed. So all in all, you can see that this will be the internal structure of any block which has been part of the blockchain networks. So nonce is all about what is the difficulty level of any block. So this can be viewed like this. So here we have the mechanism of consensus algorithm. So we have set out certain threshold value. So we use the property of basically the hash function. So if we will have a string which is passed through a hash algorithm, so we will get some code, and then this string when passed to hash, so that will be replicated uh, or generating some code, and that code value may be below this threshold or those may be above this threshold. So based upon this value that we calculate from this string, and then after computation of this hash algorithm, we will be able to identify that which transactions are valid transactions and which transactions are invalid transactions. But key question here is that how to decide this threshold value. So this threshold value is basically a difficult to tell. It is not a fixed value, but it will vary from application to application, and it's a difficulty level that needs to be solved, that needs to be given to some this is a difficulty level which is to be solved by a different set group of users, and those groups of users are called as miners, and it will be an open problem, and this open problem will be solved by some individual, and whosoever is able to identify or solve that particular threshold in a given interval of time, or he or she may be rewarded with finite number of bitcoin. So this is all about a difficulty level, that how much difficulty level has for finding out that particular threshold value with respect to the nonce value or with respect to the input string which has been passed to the hash algorithm. So once we able to define this threshold value, so certain transactions may fall having hash value which is far below this threshold value, and certain transaction may have hash value which is above this threshold value. So based upon this, we may have the certain transactions may be declared as a valid transaction, and certain other transactions may be declared as invalid transactions. So this is one of the beauty of this block mechanism, uh, that how this transactions level processing has been done. Now there are four key components of any blockchain which has to be developed. So first of them is distributed shared ledger. So you can see that each of these nodes maintain their own ledgers, own record keeping mechanism. So they have no dependency on any centralized node. So they maintain their own ledgers, and it has to be synced or synchronized with the other nodes as well. So as soon as new transaction or new block has been added at the part of the chain, so this must be replicated to all the nodes, and then they will update their own record so that they can make a better decision in the for the next node or for the next transaction for validation and verification purpose. And second part is that it must have some cryptographic algorithm. So as I have already told you that it uses the hash algorithm as well for finding out the appropriate records from any nodes. And then a more important part is this, that for identification of an individual node, that which particular node has committed which particular type of transaction, we use the digital signature mechanism. And digital signature mechanism is based upon public private key infrastructure part, where you see that identification of an individual identity must be there. So this identification of individual identity is based upon digital signature verification. And let's say if some nodes has committed certain transactions, so he or she cannot deny that they have not done it. But so for identification of an individual who has performed certain level of transactions, we should take care of digital signature verification and validation. And this digital signature verification and validation consisting of cryptographic primitives identification. Then of course we need smart contract. So smart contract is nothing but it is a piece of code, and this piece of code is self driven in the sense that it based upon automation process. So once that smart contract which had been written in certain programming language, certain condition has been met, so it will automatically get executed. So the most important language that has been used for smart contract design is Solidity programming language, and Solidity is a mixture of C, C++, Java, and JavaScript part. So it's very easy language to write it down the smart contract. So smart contract you can view just like that. Let's say if there are multiple parties associated in a community, so they agreed upon certain conditions, that this is the deliverable and these are the instructions which needs to be followed. So so in that context there must be some agreement between all of these parties. So one way is that we will use pen and paper, and then this pen and paper will note down all those terms and condition which will lay down or foundation all of these parties. But second part is this, that instead of going for pen and paper part, we should be able to write down a certain level of codes, and these level of code consisting of certain conditions, all of those conditions which has been written down, which has been penned down between these parties, and then we will make a program in Solidity programming language, and then as soon as certain condition has been met it out, so these contracts will automatically be self-executable, or this will be get executed automatically as per the condition which has been laid down in requirement analysis phase. So smart contract is nothing but it is just like a piece of code which has been written in a Solidity programming language, which is one of the most popular language to write down the smart contract, and it will automatically get executed as per the requirement which has been penned down by different parties for any application. So this is one of the we can say key component of successful execution of any smart contract for blockchain networks. And then we have the consensus. So obviously consensus is all about how we can be able to identify the agreement between different parties, and this agreement is all about that there must be some sort of we can say agreement among themselves for successful execution of different level of instructions among the communities or among the end users. So it has been used for business purposes basically, because smart contract basically is used to uh, execute a certain level of financial transactions where different users or different we can say end users maintain the shared ledgers, and for making the for maintaining the privacy and for having the validation process, all the parties agree for the network transactions to be get executed in a seamless manner. So uh, so we can say, if we try to compare two of the most important platform which has been used for successful execution of smart contracts, so these two platforms are Bitcoin and Ethereum platform. So if we pen down the differences between these, so it is not all about different level of parameters. So for example, if we will have algorithms of a hash algorithm that had been used in Bitcoin is SHA-256, and here we have using ET hash algorithm. Here we have 10 minutes for execution of any blocks or new blocks to be added. Here we have 12 to 14 seconds has been used for uh, adding a new block into the blockchain part, and there are certain other parameters as well. So, I mean to say here, if we try to make a difference between database and blockchain ledger, so it's all about that database have a centralized administrations and centralized control, while blockchain have no administration or in charge. So only entities with having right, they can access the database. Anyone can access the public blockchain part, and only entities that are entitled to read or write can do so. But here we have anyone with right proof of work can write on the blockchain. So databases are fast, and but blockchains are slow. Here no history of record and ownerships of digital record, but here history of record and ownerships of digital record has been maintained. So as I have already told you that smart contract is all about pen and papers with certain legal procedures to be followed. But you see, there are different parties involved in this case. Like for example, like requirement analysis phase uh, to the, we can say, data collection part, to the successful execution of all those smart contract. We have different persons involved, and there may this may be a manual process which is used to be followed for certain level of execution, for successful execution of any smart contract application. But on the other side, if this terminology has to be automated, so it must have some software programs with certain level of codes, and obviously this may consisting of certain level of I mean to say terms and condition which has been laid down using certain functions and procedures, and these functions and procedures are self driven. This will be automatically get executed as and when we have certain level of condition has been met it out. So once those condition has been met it out, so these smart contract will automatically get executed. So we can say that a smart contract or smart programs on distributed ledgers will be consisting of self-executable POM, and it consisting of distributed ledgers which allow an immutability verification and secure record of all the contracts and transactions as a part of the blockchain definitions. So this will provides us more flexibility that there is no human intervention would be required. So as and when certain level of condition has been met it out, so we will automatically, this smart contract will be automatically get executed. So this will provide us more flexibility as compared with the traditional centralized architecture. You know that it will probably dependent upon a centralized node, and these centralized nodes obviously may be having some sort of problem with respect to scalability, and with respect to the fault tolerance, and with respect to the overloaded part. Then we can say there are two different types of smart contracts. So this will be the basically Ethereum accounts that had been maintained by external and internal accounts. So those are the smart contract which can be used for wide range of application. So with this, I hope this lecture will be useful for you guys. So I stop at here because